what I really like is that we built this dream together. I'm getting feedback from all of you. That's awesome. Thank you very much for all your contributions. My favorite word, I think, is from the wish list. My two favorite ones are invisible. I love that one. In fact, I have a slide dedicated to just that. I love invisible infrastructure because that's something we have never seen until now. And simple. Those are my two favorite ones from everything I've heard today. Simple and invisible. So let's see how much we can cover of your wishes. So again, an example of invisible infrastructure, my favorite example, we already talked about what invisible means in this case. It just works. I don't see it. I don't worry about it. Just like my phone, whatever is behind it, I don't care. It's just a platform. Another favorite example that I have, I don't know if it's the best example to use here. I don't know how reliable power is, but electricity. Electricity is my favorite example of invisible infrastructure because I just flip a switch, right? I flip a switch, lights come on, hopefully. And I don't know anything behind it. There's transformers, there's plants, there's wiring. There's so much stuff that I don't know about. I know that it just works. I don't worry about the intensity of the light. I don't worry about lumens. I just know that I flip a switch and light comes on. So that's one of my favorite examples of invisible infrastructure. So how do we bring this to the data center? That's going to be my next question. And again, we're going to try to explain how to make this true. Let's remember the data center of the 90s that we showed before. Again, we all talked already about how complex it is. I don't want to repeat what I said. Instead, I'm going to ask you one interesting question. We're going to get a little bit more technical now, by the way. And so feel free to just interrupt me and say, hey, Gustavo, that's a little bit too crazy when I start getting a little bit too techy. But going back to this slide, my question is, how do you turn it on? How do you turn on the data center today? I mean, it sounds easy, right? Turn on, well, is it a switch? Like the light, like invisible infrastructure I described? It is not. And this reminds me, remember, I come back from a customer perspective. I come from hotels. I remember one day, somebody with a brilliant mind, this individual had a wonderful idea. He came from an XYZ company to do something in our data center. And he decided that big red button behind a plastic cover, he decided to open that plastic cover, and he decided it's a good idea to push the button. Don't ask me why, but that person decided to do that. Needless to say, the data center went down immediately, right? You hear that silence, it's like, oh my God. That means trouble. So we all started running like chicken with our head cut off, all directions. Nobody knew what to do. And so I immediately went into the data center and said, oh my God. So when we brought the power back, the first question that came to my mind is, how do I power this on? So I said, okay, let's bring up the SAN. That was my first thought. We need the SAN first, right? So we went to the SAN. It was already booting up. And the servers, because of probably lack of planning, I must admit, servers were already trying to boot on. ESX VMware servers were trying to boot on. Switches were on. And I'm like, okay, let's pray. What else can you do at that point except for praying, right? Believe it or not, a company like that, and I'm talking again about the largest hotel company in the planet, took 2 hours to come back online. I'm not proud to say that because it was my responsibility, but it took us 2 hours to come back. I must admit it, yes, it was lack of planning. Why? There was an IP conflict from an IP address in the DHCP segment from a projector on a ceiling that took an IP address from the SAN. And the SAN couldn't boot up properly. Without storage, you know what happens to the VMware servers, right? They all crash, and there's a lot of non-existing virtual machines, a lot of zombie VMs. Everybody starts freaking out. The SAN is not available. The domain controller was not. The SAN had a dependency on the domain controllers too. So it was a nightmare. It took us 2 hours to come back. We had to power everything down, by the way, find the guilty IP taker, bring up the SAN manually, and once it was happy, then we started bringing up each one of those components by hand. And we came back online. Lesson learned. complexity doesn't help. I know it was part of our fault, probably. We could have done things better. But the lesson we learned is complexity is not helping me. So what if I can turn on the entire data center? What if I could tell Alexa to turn on my data center? I can tell Alexa to turn it off. But what if I tell her to turn it on? What if I just say, hey, can you turn on the data center? And she does it? Do you think that's possible? This is my little personal touch to the presentation today. I'm going to show you my experiment that I did myself. This is me, not the company, telling Alexa how to turn on a data center. Alexa, can you please turn on the data center for me?
Yeah.
What I want to learn from this is, yes, it is now possible to push a button and have the entire infrastructure, all the layers of complexity involved, coming online immediately without figuring out what goes first or what happens next. So after seeing that Alexa, this Alexa, not the electronic one, can power on the data center, let's go into how we are going to solve the problem. Yeah, exactly. She can still push the red button, right? The data center of the 90s that I showed you before can be illustrated like this. This is a diagram that shows the architecture that I was describing to you. 5 layers of complexity: storage, SAN, whatever type of shared storage you have, you need shared storage for this to exist. In many cases, Omari, you told me you have multiple storage systems, right? So that in some cases, like Omari, we have more than one platform. So multiple storage systems to share and to manage and monitor. We have fabric switches. I call it the interconnectivity nightmare, but some people call it fabric. I don't care what you call it. It's a nightmare to manage. Fabric switches are usually command line, and it takes a lot of skills and manual tweaks, which is not fun. And a lot of skill sets, by the way. I mean, not everyone can manage those fabric switches in between. You have HBAs connecting those switches with your servers. You have your compute layer. Whether you have rack mount servers, blades, I don't know what you have, but we have a layer of compute resources. Those servers are nothing but boxes with CPUs, memory, and drives. That's all it is, right? And by the way, the maker of those servers doesn't even make everything that's inside the box. Do you agree? So the maker of the hardware becomes irrelevant to me. I mean, yes, we all have preferences because we have better or worse experiences with certain manufacturers, right? I may like HP, Dell, IBM, Lenovo, whatever it is. Servers are boxes with somebody else's components in them. What matters, in my opinion, please correct me if I'm wrong, what matters is support. That's important. When I ask for a new drive, when I ask for a replacement, how do they treat me? Do they react immediately? Do they show up an hour later? Or do they take a week to show up? Or they simply don't care? Are they proactively monitoring me or not? Those kind of things are important. The box itself, again, in my humble opinion, doesn't matter. It's Intel inside. It's Samsung inside. It's Seagate inside. It's somebody else's hardware inside. Am I right? So, but again, we all have this layer of compute here. So right there, we have 4 layers of complexity. On top of that, we have virtualization. You have VMware, Hyper-V, Xen. Nowadays, Acropolis. You will hear me talking a lot about Acropolis, a new hypervisor that has been taking over the world. Whether your virtualization preference is, we have a virtualization layer. All these complexity, all these layers are there to serve what really matters, your applications. That's what I care about. We've been talking about how complex IT is and how far, think about it for a second, how far applications are from the data. They consume data. I don't know what this thing is. There you go. Data is at the bottom, and the application is at the top. So we've been putting data as far away as we can from the consumers. It doesn't make sense. Why did we take the data so away? 15 years ago, before VMware started, the data was close to the applications. We were not sharing anything. The database owner, DBAs were happy. DBAs had their databases in their own server. They were not sharing anything. They loved it. It was all the resources for them, right? The first time we told the DBA, hey, guess what? You're going to share resources in the same box with other applications. They said, you will not virtualize my databases. Remember those days when people said there's no virtualization of databases? Those days are over. We are virtualizing databases today. We virtualize Oracle, SQL Server, SAP, Dynamics. Whatever the workload is, we know today that we can virtualize it if it's properly done, of course, right? So yes, we virtualize. Yes, we share resources. But again, I would love to have the benefit, like 15 years ago, of having the data close to my application consumer. But how do I do that if I have this model here? So in fact, buying technology like this or using technology like this, to me, is like buying a car like this, getting all the parts separately. Getting, if the mirror is wrong, or there's a problem with the mirror, do I go to the manufacturer? Do I know who made it? No, I go to one company, I go to one maker, I said, hey, there's something wrong with the car. They fix it for me. So it's just one car, one key to drive, and I don't care about the rest, right? So complexity with the current infrastructure, I think we covered this before, but again, how we purchase things, we over-purchase. We take weeks or months to deploy. You said weeks earlier, so I'm going to go with weeks. You have support from multiple vendors. Who do you call when you have a performance problem? Somebody told me, I want this dream that we've been building together, I want this to be high performance. Andel said I want it to be high performing. Somebody said reliable. So whether it's those, who do I call to blame when I don't have that level of performance? Do I call the storage vendor, the server vendor, the network? Everybody crosses fingers, especially when there's a problem, right? So those are some of the disadvantages there. So again, how do I fix this problem? I asked this question before. I'm going to ask it one more time. The answer, of course, is hyperconvergence. That's why we are here today to discuss hyperconvergence, and this is the second part of my presentation today. Hyperconvergence is the solution to this problem. And I also told you I was going to show you some Legos, and Legos is a beautiful answer to this problem. Why do I talk about Legos? That's my favorite example of flexible, scalable, you said scalable architecture that just works. When I buy a Lego, I know I can start as small as I want. I can buy 3 pieces, right? Put them together and leave it there. 3 years later, I buy another Lego set. Will they interconnect? They work, right? There's no doubt they will interconnect. I mean, it just has to work. I don't even think about not working. So I have a limited scalability. I can grow something as big as I want. Most important, I can mix and match. I can get different colors, different sizes, different shapes. I don't care. I just put Legos together. Maybe I started building a little car, and I ended up with a big city. Doesn't matter. There has never been restrictions in the way I grow my Legos. I grow whenever I want. I don't have to over-provision or buy more up front. I can just grow and grow and grow as I want. Right? So remember, please, the example of Legos. Keep it in your mind, because we can bring Legos to your data center. Imagine, again, running low on storage, adding a Lego block for storage, adding a Lego block for compute. Let's start talking about IT now. I've been talking about concepts all day. So let's land it on IT. Bring compute, storage, microsegmentation, network, software-defined networking. Start adding modules or Lego blocks. Imagine those Legos to be 3 years old. You buy more, and those new ones perfectly fine talk to each other. They coexist in the same cluster without having to hire a lot of professional services. Again, mix and match without any restrictions. Generations, models, flavors, colors, it doesn't really matter. So let's bring this to the data center and be like the Googles. This is a picture of one of the Google data centers. The reason why I show this is not because, oh, this is what we want. I mean, we don't need a big data center like this, maybe. But what they have in their data centers is a fully distributed file system, a fully distributed platform where every single one of those boxes, every single one of them is the same. They do the same. They are storage devices. They are compute devices. They control read and write. They control the compute. They control the virtualization layer. They control the management. They are the VR ops of your data center. They are everything. What do I gain if I have a distributed system like this with a lot of boxes playing the same role, exactly the same? Do you think a Google data center has a lot of engineers sitting there managing stuff? They are not there. Those are empty. There's no people in those data centers. Because the only time that people go in there is just to replace something that is failing. There's a drive failing, you just walk in, swap it, and go. There's a whole computer failing, take it out, put a new one, plug it in, and you go. It's that simple. Imagine your Legos like that, where every single piece of the Lego block, Lego game, does the same. Distributed system is, just like the word says, fully distributed. It has no single points of failure. That's important to highlight. Not a single point of failure anymore. The traditional IT we have is a bunch of singular points of failure all talking together. So imagine, get rid of that concept, make a fully distributed system where no single points of failure exist, where there's no bottlenecks. That's also important. If we go back to the previous slide, I'm sorry, I have to. This one here, there's bottlenecks in this architecture. Not only the data is very far away from the applications who need it, and they have every single write or read has to travel all the way through that nightmare to the application who needs it. But also we have bottlenecks here. Storage controllers are the worst bottleneck of traditional technology. That's why SANs were designed or created before the virtualization even existed. You know SANs were created before VMware, right? SANs were not created for a virtual world. This architecture is not going to change, and it has never changed in the last 20 years because it was not created for this. That's why, I don't know if you have, you can share those stories with me now, but when I was in charge of those big data centers, I have 2,500 virtual machines under my responsibility. My number one headaches were performance for virtual desktops and performance for databases. My DBA, that's when I met Gilda, who was supposed to be here, by the way. She was the one saying, you know what, Gustavo? I need performance for my databases. She's a database guru. She was in charge of Oracle and SQL Server, and she said, I need performance. I don't know what you're going to do. The good news is this company had a lot of money, so money was not a problem. So what I did, as somebody responsible for that, I called my storage vendor. And I'm not afraid to say the name. It was EMC back then. I said, EMC, guess what? I have a lot of money. And I have problems. Can you help me? Of course. And they show up with an army of engineers. They sold me assessments, professional services engagements, whatever they could do. The result of the assessment, guess what? It's always the same, right? You need more of my product. That's all you need to solve your problem. It's always the same answer. I don't know why I bothered to do the assessment, but anyway. So I bought more of their stuff. And guess what? She came back and said, I don't know what you did, but the problems are still there. And I said, but I added everything they sold me. I spent $500,000 on whatever enhancements they sold me. She said, well, I don't know. Why? Because this is not changing. This model has not changed. This bottleneck is still here, regardless of how much speed they add to the drives, regardless. The funny part is storage vendors are trying to make us all think that a good way to solve these performance issues is by selling us a new technology called what? SSD. All flash. The new term, right? You know what I call all flash arrays? Zombies. Dead men walking. I mean, all technology trying to survive in a world where it's dying. We all know, if we know the numbers, if you follow the numbers in the industry, SANs and those technologies are dying. They are declining every day. With all flash, they managed to survive a little longer. But the reality is, all they did was to make this part faster. What about the rest of the nightmare? It's still there. They didn't change this bottleneck, by the way. Everything has to go through one of these storage controllers, only one. And those storage controllers are in charge of everything, rebuilding, solving. They do a lot. And every single piece of data has to go through it. No matter how fast you make the bottom part of this puzzle, the rest is still the same. What I'm trying to tell you is, no matter how much money you throw at the bottom, the rest doesn't get better. And to make it even worse, if I add servers here, this is usually where we grow, right? We buy more servers. That's common. as I add servers to my infrastructure, what happens to the performance at the bottom? Performance decreases, right? More servers, more demand, more traffic through the bottleneck, IOPS go down, performance goes down. That's simple math. No, it goes down, right? If you add demand here, if I grow here, the traffic that goes through here, it increases. I'm putting more load on that puzzle, and the performance goes down. If I keep growing here, the performance keeps decreasing. That's obvious. So again, I have a lot of disadvantages here. We know that. I'm going to go back to where I was before. So bottlenecks, the performance. I shared my story about the databases. She came to me many times asking for a solution. I couldn't deliver the performance the business was expecting for those Oracle and SQL workloads. Somebody came to present this technology to me. Somebody said, hey, you have to learn this new. And I was a little bit hesitating, but when they explained this concept of distributed everything, no more centralized points of failure, central storage, central anything. It's all distributed. That sounded appealing to me. Let's remember the benefits of the cloud. This platform looks like a cloud, behaves like a cloud, and guess what? This platform, hyperconvergence technology, is what powers the clouds today. The guys, two of the engineers who created the Google file system that I told you about earlier, that distributed system that Google decided to use because they couldn't grow with traditional technology, those two engineers decided to start a new company called Nutanix. Nutanix was funded by those two engineers from Google. They decided to bring the same concept from Google to the rest of the world. They said, well, it's awesome for Google, but it's only for Google use. Google is not going to sell it. So why don't we just create something that we can sell to the world? And companies to all sizes, small, big, hospitals, whatever you are, school or not, they decided to make this available to the rest of the world. And that's what we are trying to explain today, and that's what I'm going to try to use to solve the challenge that we have there in the notepad that David has on the table. So let's see if this technology, hyperconvergence, can solve those problems and why and how it can do it, right? So we decided to do something very simple. Back in 2009, Nutanix was funded by the two engineers that I just told you about from Google. They took 2 years to develop the product. From 2009 to 11, they sold nothing. They just decided to invest in research and development. And the first Nutanix appliance came to the market in 2011. So again, what those big Google cloud providers are using is exactly what I'm describing for you today, hyperconvergence. The concept is simple. I just take all this complexity on the left-hand side and converge it or combine it into a single platform, unified platform. I'm not saying a single box. I'm saying a single platform. It's important to mention that because if I tell you put everything in a box, you're going to tell me you're crazy, and you want me to put all my eggs in one basket. That's not going to happen, right? Instead, I want you to put everything you have in a single platform that is distributed, as I showed you before, fully distributed, highly available. Highly availability was one of the requirements, right? Yep. So it has to be highly available. It has to be self-healing. It has to know how to recover itself from those problems that will happen. It's not a matter of yes or no. It's a matter of when they happen. So this platform must also be, nobody requested this, but this was my personal request, add to the list. It must be all in a box, the car ready to drive. I don't want to buy anything else. I just want to buy this platform and have the peace of mind that everything is there included. I don't need anything else to drive my data center. Can I have that all in one with the keys ready for me to drive? Yes or no? Without buying anything, without installing anything else. I just want to buy the platform and be done. So my request, my addition to that list has to be a car ready for me to drive. How do I achieve that data center in a box, ready to drive, highly available? That's the Nutanix hyperconvergence platform. And I'm going to explain how it works and why this is a true distributed system. But again, the idea is, the concept behind it is combined storage and compute. Connectivity nightmare. That's just additional complexity nobody wants to deal with. So why don't we just put everything together, make it a distributed system that just works. and make it invisible, because what I really care about is applications, right? This thing is kind of working sometimes. But anyway, if I'm really delivering a true data center in a box, it must also include virtualization, right? I don't want anyone to lie to me on PowerPoint and say, well, you told me it's a data center in a box, but now you're telling me go and buy a hypervisor from a different company. I don't want that. So guess what? The days of paying for virtualization are over. We decided to include the hypervisor at no cost with the platform, forever, licensed forever, for life. And we decided to license this platform for life as well. We don't play licensing games. The platform is yours for you to drive, and the license is yours forever. The hypervisor, does anybody here have, I've been certified on VMware for over 12 years. So I like VMware. But how many of you are paying for VMware Enterprise Plus? Does anybody have any Enterprise Plus? No? Yeah? Huh? Just for the distributed switch. How much? Do you know how much it is? $7,000 per server for VMware license only. That's just for VMware. If you have to.
That's the price in the US.
Price in the US, yes. Yeah, I'm sorry. That's what the website says. So if I have only 2 servers in my data center, I'm paying $7,000 here, $7,000 here, just to VMware, aside from everything here that I bought. Am I right? And what are they giving me in exchange for that? Well, it's $3,500 per socket. So total is $7,000 per server, assuming 2 sockets per server. Assuming, yeah, of course. I just made an assumption. Yes, you're right. Sorry. So if I have dual sockets, that's $7,000 per server. That's a lot of money. A lot of money to pay for what? For a hypervisor that we take for granted today. To me, I come from the virtualization world. I'm passionate about virtualization. To me, virtualization, a hypervisor, should be included in every server I buy. It's like a CPU. I don't buy a server and I go buy a CPU separately. I expect the server to come with a CPU, right? Same thing with virtualization. It should come with a hypervisor. But they are making me pay for it. So whether I use VMware or not, or any of the other hypervisors in the market, I have to pay for them. Microsoft has made me think the hypervisor is free. It's not free. We are paying for it in the enterprise agreement, or somehow. They are not giving it away. So what if I tell you we can do this data center in a box, comes with free virtualization forever, and you can do anything you do with your hypervisor today? You mentioned NSX. NSX is a company they bought to do microsegmentation and software-defined networking. What if I do all that for free as well? What if I decide to just include it, because we are not in the business of charging for hypervisors. We are in the business of enterprise cloud computing. Our hypervisor comes included with this platform, but we are all about freedom. We are all about choice. So we will never try to lock any of you into a single platform or a single hypervisor or a single OS. So we decided to create this platform with the idea of you choose your hypervisor. You choose your public cloud if you want to connect to the public cloud. You choose your hardware platform if you want. We are all about freedom. We are a software company. I want to make it very clear today, because there was a big confusion a few years ago. People were looking at us as a hardware company. We are not. Why? Because they saw this box. Everybody saw this box, and they said, oh, Nutanix is bringing a box to the market. It's a hardware company. I understand. The only reason why we decided to use this box is to make your experience easier. We wanted to deliver, just like Apple delivered everything is ready to go, we delivered everything in an appliance. But we don't make hardware. We use Supermicro hardware, for example. So the concept of hyperconvergence, now that you mentioned the word again, it's 2 words in one, right? Convergence means combining all those elements. That's the first part of it. The funny thing is, a lot of companies that are trying to follow us, they got stuck on that. They are saying, oh, I can converge too. I'm like, yeah, but that was the first step into the journey. That was back in 2011. We are way beyond that now. Our vision is way ahead. So hyperconvergence was our first step into the enterprise cloud vision that we have. We want to become that. We became that cloud orchestrator that I was telling you about earlier. That orchestrator in the middle of the public, distributed, and private cloud. So going back to hyperconvergence, if you take those components, you combine them all together, And then you put software on top of it, which is the hyper portion of the word. You put a software intelligence layer. I told you about software defined earlier. So if you put the software that makes everything we've been writing on that notepad possible, that's what hyperconvergence is. We created the concept back in 2011, and we delivered the product in any way you want. I was telling you about hardware platforms. We believe in hardware freedom. We believe in hypervisor freedom. So you can use anything you want. Even you may like Hyper-V for some reason. Well, put it there. We don't recommend it, but it's fully certified. VMware, Xen Server, Acropolis. Acropolis is KVM. Is anyone familiar with KVM? Have you heard of KVM? KVM is a hypervisor that has been around in the market for so many years. Government institutions, federal governments, highly secure environments. Well, Amazon runs on KVM today. They announced it 2 months ago. When they announced that, our stock option went to the roof. You know, KVM is powering the most complex and most sophisticated data centers on the planet today. The only reason why it was not very popular, it was for certain environments, and it wasn't user-friendly to manage. We solved that problem. We put a nice interface on top of it. But KVM is a proven hypervisor that has been available forever. So take KVM, which is now Acropolis, take your freedom of hardware, and take the concept of distributed system, and that's a hyperconverged environment. So this is an example of one of the most popular boxes we have in the market today. And again, please remember, I'm not trying to tell you to get this box. A lot of people tell me, well, now I'm confused. You're telling me that I'm locked into your hardware. What's so special about your hardware? There's nothing special. It's not my hardware. We use commodity hardware. Any server, well, not any server, servers with certain specs, but it's commodity hardware. We decided to use Supermicro hardware just to make it easier for us to deliver your whole experience together, hardware and software. But we are not married to this platform. This is the most popular. Probably 70% of our deployments worldwide are running on this platform. The platform NX, Supermicro hardware. And the beauty of this is the density. We came up with the idea of 4 nodes per box. It's just a 2U box with 4 servers inside. We call them nodes. Hyperconvergence is based on the concept of nodes.
We have it's not hyperconverged, but it's a chassis like that with.
Maybe a blade chassis?
Yeah. And funny enough, in the one box, it has two nodes.
Okay.
And one of the nodes failed, and we had to send it back. So forgive me when it comes to hyperconverge in terms of one single, what we call chassis.
Correct.
To run your entire production on. But I guess with this, it has 4.
And you brought up a very good point. You reminded us that we don't want any single points of failure, and we want a system that is really, truly resilient, right? That was the term that we used.
Reliable, right.
And you don't want to go through that nightmare of losing a node and then your entire production environment degrades. So let's explore how this works to answer your point. But again, I'm showing 4 nodes in a single box just because this is the most popular model that I have ever seen. I mean, people love this because of the density. We all care about cost, right? Power costs are very high, especially here. So, you know, getting density, getting 4 nodes in a single box allows me to save a lot of money in rack space, cooling, and power. Now, some of our customers choose to have those 4 nodes in separate units, separate boxes. Maybe 1 U node, maybe 2 U nodes. I don't know. There's so many different models today. Whether you want to see them separately or together in a box, let's say you have a data center with 8 servers, 8 nodes. Do you want all those 8 in 2 boxes like here, 4 plus 4, or do you want to see 8 boxes? It's up to you. You have the freedom to choose.
In terms of the connectivity from box to box, would the backplane in this be faster than if you were to single them out?
If I give you a backplane, or if I give you something in the chassis that is active, what I'm really giving you, first of all, I would be lying today, and I'm not here to lie to you. I will be selling you blade chassis, blade technologies from the previous decade to you under a new name. That's not fair. Blade chassis were a box with a single point of failure and a lot of servers inside. Great idea for density, but guess what? What happens when the chassis goes down? Bad day, especially if you put a lot of servers in that chassis, which is supposed to be the goal, right? So yes, good idea for density. No, not good idea for high availability. Blades, and I had that experience at my previous job. We had a blade chassis going down. The chassis itself, not a fun day for anyone. Yes, the manufacturers tell us that the blade chassis has redundant components. I'm sorry, but that's BS. Blade chassis go down. This chassis itself here, by the way, the chassis is free. You know why? Because it has no active components. It's a metal box. It's metal. Metal has no failure points. Oh, yes. Yes.
But I think one of the questions I hear him asking is, this box by itself operating within the speed that it has, if you were to add another off the box and connect it, if the speed within that box or the speed with the other box, is there any variation in speed?
Yes, so how do we interconnect, and how does the speed change as I add more? Okay, let's address that question. First of all, I wanted to make it clear, the boxes itself have no single points of failure. They have no active components. The box is a chassis. Inside, you have 4 independent servers, 4 totally independent nodes. Again, they can be separate boxes. Remember that. I'm just showing you density because it's a good example for cost savings. Each one of these nodes has network ports, their own network ports, 10 gig, 40 gig, 1 gig, whatever you like. Each one of them is totally independent from each other. You connect all of those nodes to the top of rack switches, right? We are using a standard Ethernet network that you already have, by the way. Right? Whether you want to put new switches with this technology or you want to use your existing switches, we just plug in there. But I want to make it clear, every single one of these nodes has 10 gig connections or whichever network connections you need, and we use Ethernet connectivity. We don't want to use that fabric nightmare anymore. We believe networking is at the point where it's faster than what we need. I mean, 10 gig, 40 gig networks, I mean, they are more common nowadays. So they are, number one, to answer your question, is number one, each node is totally independent from each other. It's connected to the network, right? The second part of that question was, there's 4 servers in a box, basically, yes. Imagine the blade concept without a single point of failure, right? There's 2 power supplies shared in the middle. These are the power supplies here.
Okay, so those 2 power would actually be
The 4 nodes, correct. Yes, yes. There was another question?
I was just saying, there's no, like any bus controller inside the chassis connecting
Correct.
all 4. So the speed, regardless, would be network.
In fact, I was going to answer the second part of your question. The speed, when you add, let's say you have 4 nodes fully populated, and you add a number 5, we send you a new chassis free of charge because it's a box with a number 5 node in it and 3 empty spaces, right? And you know what happens to your system at that point when you add a new node? The performance now goes up. It's a totally opposite behavior as before. When we added servers, the performance went down, right? Now your performance is going to go up, and I'm about to explain why in one of the next slides. But as you grow the system, your performance grows. I know, this is the point where it starts getting to like, okay, this sounds too good to be true. Yeah, I know that. I'm used to that, trust me. And at the end of this presentation today, I'm going to say, if you want to see with your own eyes what I just described today, please test it. Please let us know. Please let's do more together so you can see it with your own eyes. But anyway.
question.
Yes.
You said that you guys are not, I would say, hardware company. You're a software. So with these 4 servers in this one box, is there like a dedicated server or dedicated storage area or something that manages that software that will allow for the communication between all servers or all nodes?
Yes, there's a software layer that I'm about to describe in a second. Yes, that's correct. But you're right. There's software orchestrating all this because at this point so far, all I've shown you is 4 servers.
And then now this software, it knows to link to, say if you have multiple blocks, I'm going to use the word I have here. If I have multiple blocks.
You're using our terms. Yeah,
yes.
Thank you.
This software knows to see these blocks and work together.
Be aware of the nodes. Yes, absolutely. Where the nodes are. Yes.
It is very important to note that what Gustavo is showing is the hardware layer. And what he's going to show you next is a software that makes the hardware work. The hardware you can buy from any vendor. If you like Dell, buy Dell. If you like Lenovo, buy Lenovo. This is based on Supermicro. So if that's what you want, you could buy it from Nutanix themselves. But don't get hung up on the hardware itself. What we're trying to show you is that each node is independent. Independent network, independent motherboard, independent memory, independent storage. The only thing a converged box like this has is your shared power supply. And when you look at blades from the past, and I know that's what you're used to, those have shared bus, shared architecture in terms of how it does networking and all of that. This chassis or this frame is just metal with power supplies. That's all. But if you want, you can actually have individual servers. So it all depends on how big your computer room is and your preference. So what is good about software-defined data center is that you have choice. You can go dense or you can go not so dense. And at the end of the day, it is a shared nothing architecture. And you can actually have completely shared nothing architecture. It's a software now that brings that storage together, the software that brings all the compute together, and it's a software that makes it hyper-converged.
As Sondel said, so far all I've been showing you is 4 servers. That's all I've done. I haven't touched on the software. I'm just still living the dream that we have on the notepad. Again, form factor, up to you. If you don't care about cost savings in terms of power and you want 4 servers separately, that's perfectly fine. If you like density, again, dual power supplies. I mean, 2 power supplies dying at the same time is almost impossible in my opinion. So, but if you want the redundancy of separate boxes, we deliver that. It's totally up to you. I showed this model because density and savings have become very popular, and it's actually the most popular model since we came to the market. Yes?
All right. You say we can use any vendor, right?
Correct.
How do you, Nutanix, let me say, protect yourself in terms of the performance that the hyperconverged software will give? If I buy, say, for example, a Dell server and I say, hey, this is what I want, this is what I want you to put it on, and then it's not, the performance is not up to where I want it, how do you say to me that it's not the software, it's the hardware?
Well, the reality is that was one of the problems when we relied on hardware. We were thinking hardware would deliver something to us, and then when the hardware was not there, then we had problems. When you pass that responsibility onto the software, it's really up to the software to make decisions and deliver the performance you want. A CPU is nothing but a certain number of gigahertz. Are you with me? The CPU is not going to change. It doesn't get better or worse. A CPU is a CPU. That's simple. Memory is the same. Memory is, you have a number of gigabytes, and you have types of memory, DDR4 or whatever it is. And then you have a third component, drives. Drives can be SSD or mechanical drives. Mechanical drives give you a certain number of IOPS, and the SSDs give you a higher number of IOPS. But those numbers don't change. What I'm trying to say is, if I build my infrastructure on a, let's say I have 4 nodes. Those 4 nodes came with 2 CPUs, 3 gigahertz each. That is not going to change, regardless of what I put on top of it. Are we in agreement there? That doesn't change. What changes is the software that is managing those resources. And today, as of today, all you've had is a hypervisor trying to make invisible or abstracting that layer and trying to play with those resources. So again, models, just like Legos, we have different types of Lego blocks. I mean, some of them are storage heavy, some of them are compute heavy, some of them are storage only. We have different types of Legos, different models. Again, I'm showing you the boxes with the Nutanix logo. That's the Supermicro hardware. Again, it's because only is the most popular, not because we are trying to impose that to you. But again, the experience, the quality of the hardware, the support that we can deliver to you locally is second to none when you use this family of hardware. Okay? But again, you have total freedom to use whatever you like. So again, like Legos, different sizes, different shapes, storage, compute, balanced. It's up to you. With graphical cards, things like that, it doesn't matter, right? And at the end, just to reinforce what I just said, you have the freedom to choose any hardware manufacturer. You know, we have the Nutanix flavor that I just showed you, and all the major vendors. We have a compatibility list available. You can also choose, going back to our cloud topic, if you want to connect this platform to the public cloud for some reason, we have a freedom to choose AWS, Google, Azure, whatever you like, and a new one that is coming very soon. That's a little hint that I want to share with you today. You will see a new one now that is not very popular yet. And you also have a freedom to choose hypervisors here, right? Whether it's Acropolis, AHV, VMware, Hyper-V, whatever. So total freedom of choice. All right, software. Let's talk about how this works behind the scenes. This is going to answer a lot of the questions, I believe. Let's imagine a 3-node cluster. The smallest cluster we can provide to you is 3 nodes. To guarantee the experience that I've been describing here today, a highly available system, a fully redundant, a fully self-healing system, to deliver all that to you, I need at least 3 nodes in production. After that, you grow anywhere you want. So the box that I showed you before, if you buy it with 3 nodes, it comes with one empty space there. It's that simple, right? Just to insert a new one whenever you like. So imagine this system with 3 nodes. At the end of the day, you have in each node, which is basically a separate server, right? You have a number of VMs. You have a hypervisor running on it. And you have your hardware in that node, CPU and memory and drives. We also have a number of drives, SSD and mechanical, in each one of the nodes. All those drives are aggregated together, and we present them as a single pool or a single volume, so to speak. For those coming from the VMware world, we can call it a single data store, right? I know VMware and storage vendors told us many years ago, no, you have to create many data stores. Do not put a lot of VMs in the same data store. Those days are over. Forget about that. Because now with the old way, you end up with a lot of data stores, each one of those wasting a little bit of storage. Am I right? So forget about that. Put everything in one single pool, which doesn't have the penalties that you used to have. We aggregate all the drives from all nodes. We put them all together in one volume, and we present that to your virtual environment. That's how the cloud works. The cloud works in the same way. They all see a big pool of resources. We do the same. We aggregate all the CPUs, all the memory, all the storage. We put it all together in a single cluster. And all you have to worry about is create virtual machines, manage virtual machines on the hypervisor of your choice. We are making invisible the rest because we want you to focus on what really matters, which is creating those applications, delivering those applications, creating virtual machines. One of the questions that I still have in my mind was around performance. You said, well, how is performance going to be affected every time I grow? We have, our software runs in a virtual machine. And there's, I don't know if you can, it's blue, this one here. There's a CVM, a controller VM in each one of those hosts or nodes. Our software runs as a virtual machine. It allows us to be flexible. It allows us to be in the cloud, at home, wherever we want to be, as we are a virtual machine. And our software is in charge of every single task in the data center. We control input, output. We control data protection, replication. We control every single aspect of the data center in those CVMs. And guess what? Those CVMs talk to each other in real time, all the time. They share management. They share monitoring. They share IOPS. They share data protection. They share every single responsibility. It's a truly distributed system where all the intelligence in Nutanix lives everywhere in the cluster. Each CVM provides IOPS. So when I add a number 4 node, I'm delivering also a new CVM, and you're delivering more IOPS, and of course, more compute power. Every node provides storage capacity, IOPS, more intelligence to the cluster, more orchestrators, so to speak. So to speak, the CVMs are orchestrators, right? So each one of them is delivering more intelligence, more IOPS, more compute, and more storage to your system. If this one dies, let's say it dies, it's software, right? There's a chance it may have a conflict and die. The rest of them have the capability to rebuild it on the fly, recreate a new one if necessary, and they take over the rest of the cluster live without any disruption whatsoever. We are talking about one of the wishes in the wish list was a self-healing system. We have the capability to rebuild anything we can live in real time. We also have an option called data locality. It's not an option, it's a feature. Data locality means VMs read and write data local where they reside. Every node keeps the traffic local, so the data doesn't have to travel that nightmare anymore. Data locality is unique to Nutanix. Nobody else can do this. Data locality means data stays local. This goes back to the days where the databases were not shared with anyone. The data was local, remember? There was no SAN back then. Well, imagine that performance before the SAN days. Imagine that in a virtual world. You have that performance now because we keep the traffic local. We store the data locally, but we, behind the scenes, we replicate it somewhere else in the cluster. Where? The software makes the decisions. The software knows that two nodes are in different boxes, so it's better to put the copy of the block or the copy of the data somewhere else. It makes the decisions about where to place a VM, makes the decisions proactively about where to keep certain virtual machines based on demand and based on capacity needs. And remember, these nodes can all be different. They can all be different flavors, sizes, generations. You can even bring a node that is 3 years newer, put it in the same cluster. Let the software make them all the same. It's one pool of resources at the end of the day. Critical things like compression and deduplication are all controlled by the software. And remember, the software is not in a single place anymore. The software is everywhere. Opposite to all technologies like RAID, I can lose a drive, I can lose 2 drives, I can lose 3 drives, I can lose 6 drives. I don't care. I simply don't care. In the old days, when I lost a second drive, I was praying at that point, right? I was going to backups. So losing 1 or 2 or 3 things doesn't matter anymore. In fact, losing one entire node doesn't matter. In a 3-node cluster, I can still lose one full node, and I don't care. What's going to happen when I lose a node? These VMs automatically, of course, get migrated to somewhere else. And remember, the data that these machines had local, it's already somewhere else in the cluster. It's already protected. I lose a drive here. New copies will be made, of course, just to keep it resilient again. It knows how to recover. If it can't recover from a failure, it will start making new copies to keep us safe while the part is replaced. We just got news about part replacement, right? We have a local part depot in Jamaica now, opened just a week ago. Since we have already many Nutanix units in the island deployed, we now deployed a part depot. So part replacement is not even if we didn't have the part depot, let's put it that way. Let's say we don't have that, and it's going to take 2 days to arrive here. It doesn't matter. When you have a system that is resilient like this, that is self-healing, that it can tolerate any type of failure, it doesn't matter if you get a failed drive to arrive in a day or 2. However, that's not the case anymore. We have everything local now. Yes?
Have you had any instances where the controller VMs ran into trouble, because that could be disastrous?
Absolutely.
Yeah, so we're back at a single point of failure. I mean, that's where my headspace is at. It's still overcompensating by more than you need,
Okay.
but the benefit is gives you more. Yeah, so if you could answer that question.
Well, yeah, so you said 2 things that I have in my mind right now. Overcompensating, and you said there's a single point of failure with the CVM, right? So I'm going to start with the second part. That's the easy one. So having multiple CVMs solves that problem, right? I have a CVM in every single node of the cluster. So there's no single point of failure. Now I have 3, 5, 100, whatever. If you have 100 nodes, you have 100 CVMs. It's that simple. Am I right?
Yeah. The question is with 3, because there's no single guy, each of them operate independently, but closely. Yeah, I'm just trying to understand. It's software, and
Yes.
yeah, you can have a glitch. So I'm just
Absolutely.
trying to figure out, have you had those, and how have you been able to recover? Because it's 3 guys. There's no traffic cop. 3 guys decide how, at least 3 or 2 decide how things work, and
Yes.
there can be conflicts. So I'm just interested to.
And you just described the benefit of the distributed system. You just told me you have 3 traffic controllers, you call them cops, 3 cops in charge of the traffic. So if one of them, like you said, you asked me a punctual question. You said, have you had a failure in a CVM? Absolutely. Not only we've had those, we expect those to happen someday. It's a different story to be tolerant to a failure and a different one to be designed to fail. We are designed to fail. I don't care if a CVM goes down. If a CVM goes down, their other partners, they have the ability to rebuild it, reset it, restart it, do whatever they want. And guess what? Since we are a separate machine, our intelligence is not here. I know some companies put the software layer in their hypervisor or in the kernel. That's a wrong approach. If you put it here, that means I have full control of the CVM separately. I can kill it, I can rebuild it, I can restart it without touching anything else that is running here. Your virtual machines can be intact. That gives me also the ability to patch and update the entire system without touching your VMs. I don't have to move your VMs to install a software patch. That was one of the questions about software patches. When I deliver a patch, whether it's for improvement or security improvements, I just touch this part of here. I don't have to touch the rest of the platform if I don't need to. So having multiple CVMs allows me to lose one if I want and rebuild it in real time without touching your VMs that are running on the platform. So that's the number one. And the second part of the question, so CVM distributed, and I guess we can cover it in a one-on-one if you prefer. But the second part of the question,
overcompensation.
Overcompensation. So thank you. So I want to buy only what I need to run my capacity needs today. So that's why I'm giving you the option to start with only 3 nodes or go to 1,000. You buy as you need. So the idea of pay as you grow is exactly what drives us, because you may need enough nodes to just cover one project today. And we want you to be able to add nodes as you need more capacity. So I'm not understanding fully how we can overcompensate with a small cluster like this, unless, of course, your needs are only one server. If I only have one server in my infrastructure, well, yes, 3 nodes may be too much for my needs, yes.
Definitely. I mean, if you have a small business that is running accounts, maybe QuickBooks on a single server, you don't need 3 servers.
Yeah, you don't need this.
So, this is definitely for SMBs, yes, but an SMB of a certain size and above. If you need 3 servers, any at all, then this fits you quite perfectly.
All right, so benefits, pay as you grow. I just explained that. That was an answer to this point here. I just pay for what I need. I buy my first cluster based on my needs today, and I just grow depending on my future needs. If the business changes, we talked about acquisitions. Business changes, I change my cluster. Maybe I add storage, I add compute, I add newer nodes, different nodes, a second cluster. I don't have any restrictions. I can grow 1 node at a time anytime I want. I can buy 1 or I can buy 100. It's up to me. The only minimum is 3 nodes to begin. That's it. And why 3? Obviously, because I want to be able to tolerate the failure that he described. Well, you said, well, if I lose an entire node, I want to be able to run your cluster in 2 nodes. That's why we have a minimum of 3. Other than that, there's no restrictions in how you grow. Deployment. We asked that question earlier. Is it weeks, months? We agreed on weeks, right? Full Nutanix cluster deploy takes, typically we deploy in 1 day. That's our deployment time. 2 days to do the training, knowledge transfer, that's it. In a couple of days, you have a cluster up and running. Typically, the first day, everything is up and running. Second day, knowledge transfer, and we are happy to go. If you want us to migrate everything what you have, of course, that might take longer, but typically, deployment is a 1-day exercise. So deployment in hours or a day is a big differentiator. Pay as you grow. Simplified management and monitoring. All the management is in one single console that is distributed across the system, one single web console. It's called Prism. Prism is a management console, centralized, distributed, of course, that manages hardware, software, storage, virtualization, replication. Everything is included in one single console, which, by the way, you don't have to install or license. It's included as part of the product. The platform comes with a management and monitoring included. You scale on demand. The growth of your cluster. One of the questions was, what happens when I add a new node? Well, you just push a button. You say expand cluster. The cluster grows automatically. You don't have to disrupt. You don't have to stop anything. You don't have to shut down anything. You just click a button and grow the cluster. Okay? Any workload, any anything that can be virtualized can run on this platform ideally. Whether it's a mission-critical ERP, databases, virtual desktops, Exchange, documentation from all those companies, Microsoft, Oracle, SAP, is available on how to run their applications on Nutanix. Remember, this is the leading hyperconverged platform according to Gartner, according to our IDC. Every analyst agree that this is the leading platform. And third-party vendors like this agree that it's also the best platform to run their applications. What are we doing to increase performance? Am I sacrificing something? That's a question. Or am I simulating something, which could be even worse, right? To make performance look better. The correct answer is software defined. If I have a software layer managing all the hardware resources, and I know I have the gigahertz, I have the gigabytes, and I have the terabytes in disk, I know what I have. And the software just makes use of those resources in a certain way with using certain algorithms. And I make that software better in the next release. Let's use compression as an example. I compress data, right? And any storage vendor can compress data. So let's say, for just an example, I compress data at a 2-to-1 ratio. My algorithms allow me to save you 50%. My next software release improves that algorithm, and now I compress data, let's say, at 3-to-1. I save you space. I gave you extra capacity. What did I sacrifice? Nothing. It's the same drives, the same hardware. I just made my software better. And that's what we are doing. In fact, I'm going to share a chart with you that shows, it's almost impossible to believe, but it shows how the first box that we shipped to the market in 2011 via software updates got 4 times better a few years later. So we have that in a chart. It's documented how the same box with the first version of the software that we announced in 2011, 4 years later, was 4 times faster in terms of IOPS than when it came out to the market. The same hardware, identical. Not touch it. You simply don't touch it. I know it sounds too good to be true, but it is real. And it's measurable, which is better. Right? So, there was a good question about, I want to address that one too, about learning curve. I don't want to put Stacy on the spot, but especially because she's eating. But I can ask you that. What kind of learning do you have to, or training do you have to go through to start managing Nutanix? How many classes did you attend, or where did you go to train?
No class, just your overview, and that was it. So from the first day, it was rolled out into the next day, I was good. As Nutanix would, say, it's once you know virtualization, you are able to use the Prism console quite easily. You learn. It's nothing to learn. Just, knowing virtualization and knowing what to do. You get around the console pretty easily.
Okay. Thank you. Thanks, Stacy. So again, the bottom line here is, if you know IT infrastructure, if you know virtualization, and you're used to manage those complex environments, managing Nutanix with Prism is a piece of cake. That's what I want to say. I also covered the growth, the way you grow. You just add nodes as you want, and you have 0 restrictions. Remember, let's say you have a VDI environment. I'm using this chart as an example, just an example. I'm not promising you any capacities. I'm saying, if you have an environment running 400 virtual desktops in one Nutanix box, just an example. It's a real example, but it's just one example. One box. That's a 4-node box, yes. This is the number of nodes here. I have 4 nodes, 1 per box, 4 nodes per box. Let's say you have 400 virtual desktops in one box. The growth is linear. What I'm trying to show in this graphic is it's more predictable for you. If your business requires 100 more virtual desktops, you know exactly what you need to buy. It's not rocket science anymore. You say, well, I have 400 now running in 4 nodes. It's 100 per node. I add a 5th node, and I have capacity for how many virtual desktops? I have 100 more automatically. It's that simple. So budgeting, predicting, asking for money gets a lot easier because you know you have one single platform to grow. I'm not saying it's not going to grow. I'm saying it gets a lot easier to grow because all you have to do is add more pieces to the Lego. Business grows, you add one piece to the Lego or two pieces or whatever it is. You have only one thing to buy. You don't need anything else. Your software grows, the platform grows, performance grows, everything grows automatically.
All right, one of the concerns I've had about this approach is that we're moving from a very SAN-intensive, very large data-driven environment. I might understand that these are essentially going to be storage bundled with the appliances right across here, right?
Yes.
Do you have any models where it's more of a storage only, like a block of storage rather than an actual processor with step on storage?
Yeah, I don't know if you remember the slide with different colors, different blocks. I showed you all the models. We have storage heavy, storage only, compute heavy, compute only.
What's the capacity
all kinds of flavors.
of those?
Our storage only node right now, one single node can give you 80 terabytes, 80.
Okay.
One single node.
Cool.
And there's a very easy rule in Nutanix to calculate your usable storage. Very simple, just divide it by 2. Why? Because we use replication factors. Remember I told you in the technical slide that we make 2 copies of the data? So if we are making 2 copies of the data, it's that simple. If I give you 100 terabytes raw, you have approximately 50 terabytes usable. That simple. Now, those 50 will get better because if you add compression, deduplication on top of that, it may be 70, it may be 80. By the way, if you see a company promising you, without even knowing your business, knowing your data, that they will deduplicate or compress your data like 100 times of what you want, automatically you know that company is lying to you. It's impossible to promise something like that without knowing you, right? What if I store CCTV videos? How are you going to compress those? It's impossible to compress them. So if I don't know you, I can't promise you anything. What we do in our management console is we give you a good real-time view of how much you are saving if you enable our compression and our deduplication. We show you how much you are saving with your data. So let's move on to something we haven't even discussed, but it was also in our wish list. I'm going to ask you, David, I know you're eating, but I need to start mapping each one of those wishes to features in Nutanix so we can cover everything and decide if it's true that our dream can come true or not. One of the requirements was high availability. We decided if it's a true data center in a box, it has to be included in the platform, data protection and replication. I don't want to sell you another software. I don't want you to install another piece of software. I don't want you to buy anything, again, from us. What I want you to do is to know that this is included in the platform from day one, whether you use it or not. Just like our hypervisor. You want to use Acropolis? Fine. You don't want to use it like our friends at Jamaica Boilers. They felt more comfortable using VMware? Fine, too. You don't use Acropolis. You save it for later. Eventually, I have a feeling everybody will, but for the cost savings. But anyway, data protection. You have several options. Option number 1, replicate to your local cluster. Protect the data in the local cluster. We have what Apple calls the time machine, right? And the laptops. You can time machine your laptop back. It works beautifully. We did the same thing in the data center. You can restore a file, a VM, or the entire data center to the way it was an hour ago. And you had a question around backups too, so that I wanted to remember that. You can restore files, you can restore VMs, you can restore the entire data center to the way it was an hour ago, a day ago, or a month ago. It's all built into the platform. That's local. Option number 1, protect your data in the same cluster. Why locally? Because that's what most of the backups and restores happen, right? You don't have disasters. You don't have hurricanes every day. You have people losing files. You have applications corrupting data. So protect locally, number 1. Option number 2, remote one-node target. We recently announced one-node targets. We have support for 1-node or 2-node clusters for disaster recovery purposes, not for main production. Remember, main production, minimum is 3. But for remote locations, you have a small branch office, you have a hotel that requires a little bit of infrastructure. We now support 2-node clusters for those remote locations, replicating back. So whether you have a 1-node cluster in a remote location or in a remote closet across in a different office, or you have a full remote cluster in a different building, it's up to you. All the mechanisms to do replication are there. protect machines regardless of what they are. We don't protect volumes or LUNs. We protect virtual machines, applications. So everything is there, ready for you to protect Nutanix to Nutanix, different models, even different hypervisors. We are the only technology today that allows you to have VMware in site A, Acropolis in site B, and protect each other if we want. So meaning you have machines running on 2 different hypervisors on different clusters at the same time. That's a reality today, yes.
If I have a 3-node, it's a 3-node cluster, that's one box, and you guys are running periodical updates. Is it run per node, or as like a testing, or does all the nodes get updated at the same time?
Well, you touched one of the very nice features, and I'm going to have to ask. I'm going to ask a customer. I'm sorry, Stacy, can I put you on the spot again? Sorry to interrupt. Have you used, I always say that we are proud of saying that we are the creators of the one-click upgrade experience. That sounds too good to be true. Have you used our one-click upgrades ever in your clusters?
Yes, once.
How was it?
Was pretty fast and easy. It's as
Was it a
says,
real one-click?
one click? Right, it is.
So I wanted to ask Stacy, because it's better if you hear this for somebody who used it. Thank you. It's a one-click experience to upgrade the entire data center. It doesn't matter if you have 3 nodes or if you have 100 nodes. One click upgrades the entire platform. We in Nutanix, we pre-validate, pre-test, and pre-configure all those upgrades to make sure they will be non-disruptive. Now, we are touching software only. That's the beauty of this. I can touch the CVM, destroy it, rebuild it with a new version on the fly without touching your VMs. Your VMs are still running, right? I'm not touching the host. If I have to upgrade the hypervisor too, which we do, that's, of course, we take care of moving the machines around so we can upgrade your hypervisor. But the upgrade experience is a one-click for the entire platform, all the components included. So the question is, in my previous example of somebody pushing the red button and shutting down the data center, what Nutanix does? Well, there's nothing we can do, right? I mean, we lose power, you lose power. I mean, the data center is down. Now, if you are using our replication, then the other cluster takes over automatically or manually. It's up to you to decide. We have sync replication, async replication. If you want real-time failover between offices, you can do that. Our friends at Jamaica Broilers have separate clusters for failover situations. Do you want real-time? We can have both active, ready to take over anytime. Do you want async? Because maybe your links are not fast enough, and you want async replication every hour, every minute, it's up to you. It requires nothing except for your Nutanix clusters. Nothing, absolutely. It just requires one button to fail over your entire data center to the other. Now, after the last hurricane season with Maria, we had a very nice case. I think it's on the web, I believe, where an entire island failed over everything, all the Nutanix workload, to another island with one button. The owner of the Nutanix on the second island was not very happy because he ran out of resources. He's like, what's happening? The other guy didn't ask him about migrating. The hurricane was coming. It was going to hit only one island. So they pushed the button. They migrated everything real time to the other Nutanix. This guy ran out of capacity. He said, hey, my cluster was at 40% this morning. Now I'm 90%. What's happening? Well, they failed over an entire island to them. So, but it was great for us because they said the hurricane went by. We shut down our data center. We had time because we moved all the Nutanix workloads to another site. And they were happy. Power comes back. You just say, OK, I want my workloads back to where they were. Absolutely. I want to wrap up the data protection and business continuity portion because I don't think I did a wonderful job about giving you the full picture. Remember, it's included in the platform. We can replicate in any direction. You can also use clusters not anymore dedicated to DR. You can have production here, and cross-protect each other. I love that one because you don't have to waste resources anymore. The replication, what I'm trying to show here is any direction, any way you want, across hypervisors, without limitations. You can do it with Nutanix without installing a single piece of software, without buying anything else. Now, one common question that I hear a lot is, oh, so then I don't need a backup software, right? I mean, there was a lady here asking about backup a second ago. So she said, well, what about my backup solution? So I want to make sure I address this correctly. Backups are important. We all want to back up our data. Yes, the platform has built-in data protection. Yes, the platform has built-in restore, time machine, high availability, whatever. But you still want some sort of backup in order for you to protect your data at the application level, in order for you to back it up to any target. What if you want to back up to an old SAN, an old NAS, or some drive that you have sitting there? Those things can only be done using a specialized backup tool. Backup tools also get down to the application level, right? If it's a database, they go down to the table or record level. If it's Exchange, they go down to the mailbox level. If it's Active Directory, they go down to the OU level. Those things we can't do. We are not in the backup market. Yes, we included a lot of data protection and replication in the platform. We encourage you to use it, but it is not intended to replace every backup tool in the planet. You have a backup tool, by all means use it. The good news is all the backup vendors know us. They know we are taking over the market. By the way, I didn't share some numbers with you. Adoption rate of Acropolis. We have about 8,000 customers worldwide right now. I'm going to share some logos too. Federal government is the number one. Companies like Toyota, Nintendo, those big names are running on Nutanix today. 35% of those 8,000 or 9,000 customers are running Acropolis today. Huge adoption rate for us since we released Acropolis only 3 years ago. In 3 years, 35%, that's amazing. 74% of the US federal government runs on Acropolis. Huge adoption rate. What happened naturally? All the third-party companies, Veeam, NetBackup, those products are already supporting Acropolis or are planning to already. There's companies like Haiku. I like that one. They created a one-click backup tool that is as simple as Nutanix. I think they want us to purchase them. That's just my theory. So I wouldn't be surprised if we buy that company. But the reality is they created the one-click backup with the simplicity of just deploy in minutes, and you back up and forget about it. So explore tools like that. If you have a preference for an existing tool, if you have something like Commvault, whatever, use it by all means. If they are already supporting Acropolis, use it with Acropolis. If you prefer to use VMware, nothing changes from your existing backup tool perspective. It's the same. We are not going to change that. Is that clear? So in terms of data protection, that's it. Again, replication, protection, time machine, and support for any backup tool is already there. Don't worry about that.
I don't want to take over the session, but you do have connectivity for SAN on the box.
That's a good one, and it reminds me we have to talk about coexisting with infrastructure, right? So somebody asked me that question. Okay, Gustavo, what you're saying, it sounds great, at least in PowerPoint, but I made an investment. What do I do with my current SAN, servers, and so on? We know, and we realize that. Every project is going to be different, so my answer to that is going to be, let us approach you and let us talk about your particular situation to give you a better design. However, typical scenarios are, we use existing SANs as a backup target. We use the SAN to publish storage to virtual machines running on Nutanix, which is very easy to do using iSCSI or standard protocols. You can use Nutanix to publish storage to your outside servers and use those servers. Very typical case, Oracle. Oracle people like to keep it aside on a bare metal because of Oracle licensing reasons, right? Put it on a couple of machines, pay Oracle only for those 2 machines, and use our storage. So we can be a SAN for that little cluster outside us. So we can be a SAN if you want us to be. Now, I'm not encouraging you to put a lot of virtual machines on us outside us, because then you lose all the benefits from hyperconvergence. It wouldn't make sense. However, yes, we can publish storage to your servers. Yes, we can consume storage from virtual machines on Nutanix, even if that storage is from the outside, from another SAN. So we try to coexist and find the best use for your servers and your SAN. If you have an old SAN, use it as a backup target. Use it as a NAS, maybe a file server. We have NAS built into the platform. I didn't say that. Oh. NAS, it's called AFS. You can use Nutanix also as your file server, but it's distributed. It's the whole architecture that I mentioned, but imagine that on the NAS as well. We have that. But if you have a system you want to use it for NAS, use it for backup, something like that. So every case is going to be different.
Okay, thank you.
And you have a lot of talent here to help you put the best design. I'm sorry, I probably didn't give you an exact answer, but every case is going to be different in that case.
Okay.
All right, so what would I lose by using, for example, the Lenovo version of what you guys are using?
do you want me to be 100% honest here? Are there any hardware makers in the room? I don't want to get in trouble, but I'm used to say the truth.
If you want, I can get it.
Okay. You want to answer that question?
Go ahead, and then I'll come.
Lenovo has a hyperconverged line. It's called Lenovo HX. Guess what? It's Nutanix. It's Nutanix. It's just called Lenovo HX, and it says powered by Nutanix. I was at Lenovo 2 days ago in North Carolina. No, last week in North Carolina.
Is that the same with IBM and HP?
IBM announced the Nutanix family now. HP, no. We have 2 OEM alliances, Lenovo and Dell. Dell is called XE. Lenovo is called HX. It's a hardware with our software on it. Now, HP, Cisco, and what else? Well, those. That's a compatibility list. Those you have to buy. We design the hardware. If you tell us, I want HP, we give you the specs. We do the sizing. We tell you, these are the part numbers you have to buy from HP to build a solution that I'm going to build for you.
Why would I purchase my product from Dell?
Exactly.
Yeah.
Exactly. That was his question again. So why do I lose when I do that? So I'm going to be 100% honest, even if I get in trouble. Number one reason, in one single word, support. It's that simple. Look at NPC. NPC's Net Promoter Score is an entity that measures every technology company in the world today. 4 years in a row, we are the top of the list. And no technology company in the planet comes close to us in terms of support. We eliminated support level 1. We have senior engineers from the beginning, from the moment they take the call. It's that simple, and we have the highest satisfaction rate. So if I give you the box with everything, I support everything. If you buy from Dell or from HP, fine. From a hardware perspective, I don't care because it's CPU and memory. Nutanix, I don't care. But your support experience is going to be now 2 people. And if that person doesn't know Nutanix well, it's not my responsibility. I can't guarantee what they are going to do. That's my only reason. Now, having said that, it's an OEM agreement. It's a global OEM agreement. Both companies have dedicated resources. So I'm not saying you will have a bad experience. I'm saying I can vouch for my experience from the Nutanix perspective, and my friends at Jamaica Boilers have experienced our Nutanix support. They can tell you all about it.
And just to add to that, another thing that you lose is there's a bit of a, what you call a brand tax that you pay with going Lenovo, going Dell, going Cisco, going HP. There's a brand tax because as far as they're concerned, I'm Dell, I'm HP, I'm Lenovo. And even though it's the same CPU, the same RAM, same hard disk that goes into each of those different servers, if you were to get a quote from each of those different manufacturers, one is higher than the next and so forth, even though it's the same specs. So you're paying a brand tax. With Nutanix, that brand tax is removed.
But to make it clear, you don't lose any functionality because we do the sizing. We still do the design, whether you go HP or Dell, and we tell you what to buy. We are responsible for that design. So I don't care where we run. We are hardware agnostic.
Gustavo, I have a Santa Claus wish list that our guys had asked about.
I was hoping they forgot about it.
No.
Nobody forgot about it?
We wanted us to go over this wish list again, Gustavo, and
All
just
right.
to verify how well we've hit on them or not.
Okay.
So, and I just took them down in no particular order as they were mentioned today.
Okay.
So we want high availability.
All right, so let's address each one of those items in the wish list and map them to Nutanix features, right? That's
Yeah.
what we want to do? Okay, thank you. So
yeah,
you said high availability.
Availability, yeah.
We have 2 answers to that. One, the distributed system based on non-single point of failures and based on distributed everything is the answer to that at the local level. Locally, I have high availability. Oh, that's beautiful. The Nutanix quadrant. In just 2 years, boom, we're like that. Anyway, remember, distributed everything means no single points of failure, so the whole system locally is highly available. That's the answer to that. From a business continuity perspective, I just explained that we have data replication, data protection, async or sync in real time. So that allows us to fail over an entire cluster to a remote location or to the public cloud. The platform is ready. So that's my answer to high availability.
Okay, sounds good. Scalable.
Scalable. It's very simple. We have no restrictions. You start with 3 and grow in any direction you want. Grow with storage, grow in compute, grow in both. different models, different generations, different whatever, I don't care. We simply grow without restrictions. Many people ask me about the limit of nodes in a Nutanix cluster. We have no limits documented because we don't know our limits yet. That's the reality. Our biggest customer is running 2,000 Nutanix nodes today, and that's a big environment, yes. And our biggest VDI customer is the FBI in the United States with 8,000 virtual desktops running, 18,000 virtual desktops running on Nutanix. We don't know limits. Today we say that our platform is limitless because we have no limitations documented so far. That's scalability.
Okay, tick. Invisible. How can you do that?
Yeah, invisible is a little bit hard to match to a feature, but I think what we all agree what we mean with invisible is simple works, right? When you have a platform that simply works, I have a customer who one day called me and he said, I forgot my password to the console. I said, how long has it been since you logged into the Nutanix console? He said, I don't know how many months. When he said that, I'm like, I think it's a good thing. If he hasn't had to log into my console, that means it's just working, right? And they are just enjoying it. It's production. They didn't touch it. That means it just works. So to me, invisible is something that just works, and you forget about it. You don't have to touch it because it simply works, and it simply gives you the best performance.
Okay, so my friend from Aerotel was saying service delivery, self-service.
Self-service, beautiful. We decided to listen to our service providers' friends. We decided to listen to you with those needs. And we designed a self-service portal that is included with the platform. And of course, it's at no cost whatsoever. We have a self-service portal ready for you to deliver quotas, if you want, to your marketing team, your development team, to your sales teams. You give them access to the portal. They deploy their own machines. They request their own servers. You can even deploy applications like your smartphone. You can say, I want an entire Oracle 3-tier system deployed with one click, and we automatically deploy it for you like an app store, so to speak. So we are taking automation and self-service very seriously. It's already there.
All right, so look, there's no way you can do this one now. Reliable, ability to recover from failure, self-healing.
Self-healing, we discussed that. We talked about that a lot, right? We have the ability to rebuild ourselves. Since nobody's in charge, our CVMs are always helping each other. They are distributing the load. If one of them has problems, the other ones take over. All the virtual machines in your cluster stay alive. And their friends are going to try to rebuild her. If she has a problem, we can shut it down, we can reset it, we can rebuild it. And if the problem is beyond that, like a hardware failure, of course, we proactively monitor those. We send alerts. We replace whatever has to be replaced. But the virtual machines, which is the important component to you, is always going to be available, even in the event of a node failure. The entire node failure means your whole cluster is still up and running all the time.
So I think this one is pretty much related to invisible, but it's end user unaware of the underlying platform.
I think that was unaware of the failure, I believe, or the platform. But yeah, well, end user unaware of the platform, yes, it's invisibility. So they don't care about what's below, they just care about the results. If I'm giving you a platform that is better performing, faster, better, easier to manage, cost effective, and it just works, well, I'm basically filling that gap, right? I mean, end user doesn't care; they just want the results.
So what about agility, which is really a business question?
Yeah, agility is it's a good one because it involves many things. Automation is a very important one. If I can give you what we call blueprints, I can create your business blueprint, and that blueprint is we put it in a small app store where you can just click and deploy an application. I'm making your business agile, so you can have a business unit able to deploy a complex application with one click. I can even clone your entire production environment with one mouse click and say, give me a copy of my ERP and put it here. When one mouse click makes that copy, and they can destroy, play with it, and they can just get rid of it, or they can create a second clone, or they can create 100 clones for different teams to work with. That, to me, that's agility, if I allow that to you.
Okay, well, how can you have both cost efficiency and high performance? Two more on the wish
Cost
list.
efficiency, I mean, typically in terms of cost, we help you with the financial analysis for these solutions. We normally do. If you compare apples to apples, because of course some people say, well, a server is cheaper than a Nutanix node. Yes, of course, because a server is not Nutanix, right? But if you compare the traditional data centers, SAN, fabrics, compute, all the components, management, overkill, and you compare all that to a Nutanix software-driven data center, we are always cheaper, especially over time. When we start day one, we are a little bit cheaper than traditional. But over time, the lines go like this. You know, we get cheaper and cheaper and cheaper to the extent of 50 to 70% over 5 years, typically. That's our average TCO savings, 50 to 70%. So cost savings are there compared to the correct components, of course. I want to be fair. However, it doesn't have anything to do with performance. Our platform is designed to deliver the highest and the best performance possible. We just do it actively. We do it all the time. We move things from SSD to mechanical intelligently. So we always guarantee the best performance regardless of what the cost of the platform was. So I don't see a relationship between performance and cost. One thing to mention there is sizing is important. If you come to us and you say, I want the cheapest Nutanix cluster, the smallest one you have, how much is it? Our answer is going to be, no, tell me what you want it for, so I can size it accordingly. I need to know how many nodes, what kind of specs. No, I just want that Model 1 that you have there. Okay, I give you that Model 1, and then the next day you decide to put the super high transactional Oracle databases on it, and it wasn't designed for that. We are going to tell you, well, that was not the ideal configuration for your situation. So we need to know in advance at least what your number one step is going to be, so we can size it properly, and from there you grow in any way you want. I don't know if I answered that question.
Good enough. Elastic?
Elastic, I think that goes along the lines with scalable, right?
Exactly.
Elastic, it's a pool of resources. You are not wasting resources. That's important. Somebody who was here asked me, hey, I want to use this for a surveillance project, CCTV, but I don't want to dedicate a cluster to CCTV. I would like to use it for virtual desktops and databases. I want my little single pool or my little single cloud. That's what Nutanix allows you to do. Mix and match workloads, put databases, surveillance, do whatever you want, all in one single cloud. Do not waste resources because you have one single pool of resources, and that becomes automatically elastic. It just grows.
I think one thing that Gustavo would need to mention about disaster recovery is that usually you have your active data center, your primary data center, then you have your DR site. And your DR site is there sitting down, waiting all year for something to happen. With Nutanix, you can actually have what we call active protection. So you could actually have your primary data center and your backup data center or your DR site actually running live workloads and protecting each other. So that's a key differentiator as well.
Cross-replication, yes. There was somebody here on this table asking me about how do I get it? She said, I love this, but my last project that got funding, I already spent that money. How do I get this? Typically, I just want you to remember, do not wait until you have a full refresh of your data center because that's never going to happen probably. Wait for the first project you can. Find one project, whether that project is DR, VDI, surveillance. I don't know what that project is, but find one to get your step, the first step into Nutanix, into hyperconvergence. Use a cluster for that solution, solve that problem, be happy with it, and then you automatically start testing other workloads on it, and it's natural. It's going to grow from there naturally. It's very simple.
Okay. Well, I think you've scored pretty well.
How did we do? This is our dream that we all built together, so how did we do?
We got 100% of that wish list.
Thank you. Thank you. Good.